I'm going to play with Node.js. You will watch me. You will be amused, and we will go on with our lives. It will be very fun. But basically, I don't have so many slides. I'm just going to open it up and type and like show you what sort of things that you might be able to do with Node. And I kind of hope that this will be a bit interactive, where you'll say like, no, you forgot a semicolon. I'll say, no, semicolons are optional. And then we'll, fight it out. Just interrupt me as you desire, okay? So first of all, I have to say, Node for Windows users, although I saw that there is many Macintosh users, is not as good as it could be. We're working on that. Soon, Windows will be very supported. At the moment, it's a very Unix-y sort of thing. But this will be changing in the next 6 months or so. What's that?
Don't waste your time.
Oh, no. Windows is very important, just like PHP. We don't have... So, all right. So let me just for those of you who are somewhat unfamiliar with downloading and compiling things yourself, Node is one of these things that is sufficiently under development that you want to compile it yourself from source. Okay, not all things are that way. If you install OpenSSL, obviously you just install the Macintosh ports or you install the Debian package or whatever. But Node is changing, okay? It's a living creature, and with that comes some blood, some pain, and your necessity to compile it. So this is how you do it, okay? I'm not going to go through the whole procedure, but hopefully this will work in a not unreasonable amount of time. So you download it, and you have to compile it. I'm sorry. I can't wait 2 minutes. All right. I'm going to not do compiling instructions. Configure, make install, okay? And then you get Node, which is a command line thing. It's not a GUI. It's not IDE. It's something. It's like Python, right? You type it in your command line. If you type it without arguments, you kind of get this weird prompt, and you can type JavaScript in there. Okay, so Node is a bunch of sugar on top of a very complex virtual machine written by Google called V8. V8 is the JavaScript engine inside of Chrome. It is a beast. Okay, it's a huge, very high performance virtual machine written by very smart people. That is not what Node is. Node is a set of libraries on top of V8. Okay, that takes uses its greatness to do networking things. And the emphasis is on networking. It's somehow a general purpose thing, but the focus is on doing networking correctly. And so it does it in a slightly weird way that I hope to demonstrate with a couple of examples. But first, let me just point out that, yes, you do have a REPL, and you can type, function add AB, return A plus B, and add two numbers, right? So that works. There's a global variable in Node. So in browser JavaScript, you have this window variable that's like this global thing that somehow ties you to your site. Well, that's because you're in a DOM. You have a window that you're playing with. In Node, you're not associated with the browser. So you don't have this window object, you have this process object. Okay, and so process is a global variable, and it's kind of central to Node. So for example, process.pid is the PID. We get bugs if we don't have semicolons. That's somewhat true, yes. But I'm just kind of playing around, so hopefully we won't get any bugs. If you just type process, you'll see all the stuff in process, which is actually kind of a lot of stuff, like process.inv, which is the environment. Okay, so you have this read eval print loop, which is what you do when you execute it. But of course, you can run scripts too, which is the most useful thing. So let me write a little script. So I'm going to do this, and hopefully it doesn't freak you out. Okay, close your eyes. Okay. So what I'm going to do is write a program called helloworld.js. Yes. Thank you. So obviously you open up your text editor, the only one that you ever know and love, right? And you start typing a little program. So I'm going to indent it a little bit because it doesn't work on the video. But so do you all? Launch Vim from inside Node, or No. I'm just launching it from Bash. Okay. Same old plain stuff. Do you guys know what set timeout does? Does everybody's somehow familiar with browsers and stuff, right? And so you have set timeout in the browser. And what set timeout does is it has two arguments. The first argument is a callback. And the second argument is the number of milliseconds that you want to wait. Okay, so I'm going to type this program. And I want somebody to tell me what it does. And now you hopefully, well, I guess a lot of you raised your hand. But so intuitively, what do you think this does? Right. Okay. So hopefully, as you guys said, it prints hello, waits 2 seconds, and then prints world. So let's try that. Node hello world. Hello, waits 2 seconds, and then world, and then it exits. Okay, that's good. So one of the points I want to make here is that Node should be somehow familiar to JavaScript people. People who are familiar with browser-side JavaScript should just feel comfortable. Not because it's JavaScript necessarily, but because we use the same word. I mean, we could have called this sleep, right? We could have said sleep there, and well, you would probably get it too. But we try to use the same terminology where possible. So there's something weird about this, which is different than how you might do this in a different language. I think in PHP, you might do something like this. Do you say print in PHP? Yeah. So you print, and then you sleep 2 seconds, and then you do world, right? Okay, so right, this is how you would do it in PHP. So what's the difference between these two? These two programs, like there's something fundamentally different here. Like, right, okay, so notice in this one, the hello happened immediately, right? We went right through that set timeout. And here we kind of stopped on the sleep, right? So that is the fundamental difference in Node, is that you never ever stop. Never do you sleep. Never do you fetch a URL from a website and wait for it to come back. Like not only are you discouraged from doing it, you simply do not have the ability to do it because it's sealed off from you. You cannot sleep in Node. You can set timeout.
There's no wait on states?
There's no wait on states. There's no mutex locks. There's no sort of possibility of just halting execution. You can idle. Okay, so this program, when it's during those 2 seconds in between the hello and the world, it's not like spinning in a busy loop, right? It just idles. The CPU goes to 0. The OS unschedules it, does other things, updates my clock or whatever, and then schedules it back when the timeout is done. Okay, so Node is good at idling. It doesn't sleep though. Okay, so let me just kind of improve on this example, and maybe I'll go slightly faster now. So let me CP hello world into hello world 2. I'm doing it this way so that I can give it to you later. What if I change that set timeout to set interval?
Hello, world.
Yes, hello, world, world, world. So let me do that. Hello, world. Oh, wait. That was the wrong one. Hello, world, world. Okay. Maybe we should have used something less than 2 seconds. Yes? Oh, excellent question. So why did the first script end, and why is the second? So notice that script exits, right? Now I can type ls. But if on the second script, I can type ls as much as I want. I'm not returned to the prompt. The process continues onward. So this brings up an important property of Node. It exits when there's nothing left to do. So it has this kind of natural ability to reference count the callbacks that are pending for it, be it a network connection, a callback waiting for an HTTP response, or an interval timer that's going to be executed every once in a while. It knows that there's something to do, and so it doesn't drop out. But once all those things go away, it drops out. So it's a good way to design your program such that you do the things that need to be done, and then it exits naturally. You don't exit the process forcefully. So this is all fine and dandy. Like, I'm sure you're like, oh, great. Okay, so JavaScript in the console. That's cool, I guess. But that's actually not so interesting. The interesting part is that this comes bundled with a bunch of kind of good libraries. And so let me write you a web server, okay? So it has a pretty advanced HTTP thing, library built in, okay, that can do both client and server-side HTTP. And so let me demonstrate to you what the HTTP client looks like. So first of all, you have to load the HTTP module, and we'll put a var in front of that so it's not global. And then you have to create an HTTP server, which you do with create server. And that thing gets a callback. So looks something like that. So that callback is executed every time a request comes into the server. Does that make sense? Which is slightly different than every time a connection is made to the server. So I'll just call the server S. And we have to bind to a port. So I'm just going to choose port 8000, right? Because I'm not root, so I can't bind to lower numbered ports. So here's the hello world thing. You write a header, which is 200 OK, content type text plain. Okay, looks good. Can you guys all see that, by the way? Okay. And then you end the response. And we'll just say, hello world. So that's your body. So headers and body. So let's try that out. So I'm going to run web server. OK, not exiting. There's stuff to be done, right? It's listening on a port. So let me go back to my thing here. And now I'm going to curl HTTP localhost port 8000. And I get hello world. OK, excellent. So we wrote a little web server. I think we can even do it here. You can do it there too. OK, so we can hit hello world. Excellent. That's good. Let's inspect those headers that it's returning for a second. OK, can you guys see that right here? OK, so the headers are content type text plain. Let me put up the server again. So content type text plain, we told it to send, right? And there's two other headers, connection, keep alive, and transfer encoding chunked. OK, so why these headers? What? OK, wait. So first of all, let me also point out that it's HTTP 1.1. Which possibly you don't care about until you realize that your server can't do HTTP 1.1, and then you get really angry. It does HTTP 1.1, the most modern version of HTTP. Why is it connection keep alive? What does that mean? Yeah, you have, it means there's persistent connections to the web server. So when you go to make a request to the web server, in the olden days, you would make the request, get the response, and then the TCP connection would be killed. But in modern HTTP, this is a persistent connection. And so you can send a request and send another request and send another request all on the same connection and get response, response, response without going through the effort of tearing down and building up that TCP connection every time. That's good. You want that. You want persistent connections. What about that? What about transfer encoding chunked? Are there any HTTP nerds in the audience?
Sending blocks of data.
Yes. You people. You're right. Okay, streaming. That's right. So it's not totally clear from this example here. We said response.end, and then we gave it some body, right? Node doesn't force you to give the entire body up front. The API actually allows you to do other things. Let me make this more explicit. Let's write part of the body first. So let's write hello, and then do a set timeout.
You want to change from end to right?
Yes. Okay, so can we guess what this will do? Yeah, so first it writes hello, and then it writes world, but it pauses in between. Okay, so you're making one request to the server, you get back hello, one body, one response, right? Hello, 2 seconds pause, and then world, and then the response terminates. Okay, so
Yeah, but then it will transmit it because it's chunked, and you don't have a full line there. Oh, you do have carriage returns in there. Okay, never mind.
the body is not terminated by carriage returns in HTTP. But let's.
The way the buffering is often handled.
Yeah, let's test it and see what happens. Okay, so if I curl it, oops, I get cannot connect to host because we have to start it. Okay, so we start the web server and we curl it and we get hello and then world. Okay, so that's cool. That's cool and all. That's why we needed the transfer encoding chunked, because if we said content length 12, it wouldn't actually work because we could have done other things. No, at that point where we wrote the response, when we wrote this thing, when we wrote the header here, we don't actually know what's coming next, right? Maybe we're making a request to a MySQL database, and it's sending back, between 50 and 1,000 lines of responses. We don't know how big that body is. Furthermore, we don't want to buffer it. Okay, we don't want to go through the extra effort of inside the web server buffering up that entire MySQL response before we send it out to the server. What we would rather do is proxy it to the client. And so when this MySQL server starts sending us a huge response with like many thousands of rows, instead of using up our server memory, we can just send it directly back to the client. So the question is, how does the browser know when the response is completed? That's part of HTTP. HTTP has a way of terminating each message. So there's different ways of encoding. So right, there, in HTTP before 1.1, you actually didn't have persistent connections. And so the way that you terminated the response was you just shut down the connection. So when the connection shut down, you realize that it's done. But now that we're in HTTP 1.1, we can possibly have more than one response. So we need a way to bound these messages. We need a framing protocol. Yes? You need keep alive for the persistent connections, but you need transfer encoding chunk to send a variable length response. Whatever. Let's not talk about it so much. What I want to say here is that when this server is doing, oops, if I don't turn it off all the time. Okay, so if I start it and do that, in between that hello and that world, the server has not shut down. Okay, it's not like it's writing that response and nothing else can happen. No, quite the opposite. That was not asleep. Okay, so we drop down and we're idle. Before that 2-second timeout happens, the server is idle. It can handle another connection. Let's see if I can I'll try to curl it from 2 terminals at once. See if this works. Okay, I have to be very fast. Okay, click there, click there. Oh wait, shit. Okay, one more time. Okay, click there, click there. Okay, so you see, did you see that it got the other hello? And in fact, what if we Apache bench it with 100 connections to it, and let's just see how long each of those request responses, we're doing 100 in parallel, but each one should take exactly 2 seconds if the server is doing what it's wanting. If the server was stupid, then the first request response should happen in 2 seconds, but the next one should happen in 4 seconds, and the next one will happen in 6 seconds. That would be if we did a sleep. But what I'm telling you is that the server does the right thing. It goes to idle. It can handle another connection. So let's see if we can do this. We shouldn't do 100 because, oh wait, yeah, I think we can do that. Okay, so hopefully this will work. Does that look right? Okay. Okay, so 1, 2. Okay, so hopefully we've done 100 request responses, and let's see if we can, somewhere in here, I think it tells us. Okay, so concurrency level 100, completed requests 100, time taken for test 2 seconds. Okay, excellent. That is what you want, right? You do not want that test to take hundreds and hundreds of seconds. So, I mean, obviously this is a contrived example, right? But the point that I want to make is that Node handles concurrency well. Because of this property that it never waits for anything, it's allowed to handle more and more connections. It's never halted on sleeping or connecting to some database or anything, actually. So it can always handle another connection. So it tends to perform much better, especially under high concurrency, than your traditional web server. Whew. Okay.
What happens when you add a 0?
What happens when I add a 0?
Yeah.
To the Apache bench?
Yeah.
To which one? This?
Sure.
Nothing, because it's not running. It should be fine. So that's 100 concurrent connections, but 1,000 responses. All right, so it's doing it in 100 batches. So I think it should take 10 times 2, which is 20 seconds or something. Does that seem reasonable? Okay, yes. So it took 20 seconds. Obviously, if we increase the concurrency, my computer can't actually handle 1,000 concurrent requests from this laptop because Macintosh is shit. Wait, hold on. Fix Macintosh port range. Okay, let's try that. It should work. Okay, so this should be 2 seconds. Too many files. I have to increase my U limit. Operating system limits, okay, not necessarily the server limits. All right, so web servers. Yes, web servers. It can do web servers. Obviously, nobody cares because you don't actually want to write a web server. You want to use a web framework. We have those, okay, but I don't make them. Other people make them, and they give talks too. This is the foundation of what you want to be underneath your web stack, okay? Other things that make it more friendly are on top of it. What the API that Node provides is very simple, but it's good. Okay, so what I want to do now is write a little, so we can do web, that's cool. I want to do now a little TCP server, okay? So getting down, you're saying, you know, HTTP, that's too much. That's like way too much overhead for me. I am cool. I do raw TCP. Okay, so now TCP server.js. Okay, so here's how it looks. I have to type frantically now. Okay, so require net. That's where the TCP stuff lives. And it looks a lot like the HTTP server. You do create server. But instead of getting a request response, that's an HTTP thing. In TCP, you just have sockets. So you get a socket. So every time somebody connects to the server, you get that socket. And then we have to bind that server to a port. So we'll bind to port 8000 again. Look cool? OK, so what can we do with these sockets? Well, we can write stuff to them. And we can terminate them. We can do more, actually. But let's start with that. So it'll write hello and then world and terminate the TCP connection. So let's see. Are you a Netcat fan or a Telnet fan? Netcat? OK. I mean, as sick as it is, I'm actually more of a Telnet fan. But OK, so let's just use Telnet. Everybody loves Telnet, right? OK, so we're running the TCP server. If we Telnet to port 8000, we get all this crap because it's Telnet. But we do get hello world in there. OK? And of course, you get connection closed by foreign host. Let's just use Telnet Netcat from now on. OK, hello world. Excellent. So, TCP server. This was only sending data. We can, of course, receive data. We being the server. So let's do that now. So when we receive some data, let's just echo it back to them. OK, so the way you do that is you do socket on data, and you give a callback. OK, so every time some data, or every time a packet arrives on that socket, we're going to do something. OK, and what we want to do is just send it back to the person who sent it. So what we can do is socket write data. OK, does that seem like an echo server to you? So we'll get hello world, and then everything after that, whatever we write to it, will get sent back. The server is never going to terminate the connection. OK, so let's try that. Oh, wait. What?
You had in still. You need to change it to right.
Oh, thank you. You guys are so observant. Yes, there's an end right there. So let's change that to right. OK, hello world. OK, Netcat is line buffered, so that's why I'm not getting it back as I type it. So that's an echo server. OK. So let's do something slightly more complicated, which is, I mean, obviously the server can be handling many connections at once. Let's write a chat server in Node so that everybody who connects to it with their clients, hopefully there's people in the room, can connect to it, and then we'll be able to chat on Telnet to each other via this. And obviously, it's going to be like the crappiest chat server ever. Yes? Exceptions. Yeah, so I'm kind of throwing that aside. Yes, there's a lot of holes in these programs that you would need to plug in a real life application. Let's just see if we can get started with a very crappy chat server. So chat.js. OK, so again, require net create server. Actually, you can just abbreviate this server. Socket. I'll just abbreviate server with S. And then S has to listen on some port. OK, so every time somebody connects, what we want to do is kind of keep a pool of sockets so that we can broadcast later on. So when data arrives, we want to kind of fire hose everybody in the connection pool. OK, so let's keep an array. Obviously, not the proper data structure for this sort of thing, but whatever, it's available. And let's just say sockets. OK, so we'll have like a little empty array where we're going to keep the people who connect to the server in. So every time somebody connects to the server, we want to put them into the sockets. So sockets push socket. Seem reasonable? OK, now we have an array that gets all of the sockets in it. Now what we want to do is every time somebody says something in the server, function d we want to iterate over the sockets and write it out to them, right? We want to broadcast. So, what? Socket.on. Yes. Is that right?
Yeah.
Okay. Var I equals 0. Let's iterate over this thing. Sockets.length I plus plus. I forgot where am I? What are we doing here? Oh yeah. Okay. Sockets I write data. That looks reasonable. Okay, chat server. Bam. Okay, so let's try this puppy out. What's that? Okay. Let's try that. See if that works. Probably won't. So node chat.js. If I telnet to localhost at port 8000, I get something. Okay, wait. Is somebody typing something? I did this before, and people went to... Oh, crap. Did it crash already? Man. People. Jesus. Hold your horses. You're ruining my demo. All right, we have to make it. We have to improve it. People are crashing it already. Just like real life. Okay, clearly this was not good enough. So what's the problem here? There's some problem, which is that we're filling up this array with sockets, and sometimes people are disconnecting. Okay, and I think that's what happened. Somebody connected and disconnected, and now this array has a dead socket in it. It's still in that array. And so when we iterate over that and we try to write to it, the server blows up and says, like, I can't write to that because that socket is dead. So what we have to do is remove those dead sockets from the array as they disconnect from the server. So we can do that with not on data, but on end. Or let's just do on close, actually. No, let's do on end. There's two termination events. Okay, so on end, on the socket end, we want to remove it from the array. Okay, so now those of you who have good JavaScript skills, okay, I've done this like 5 times now, so I think I can remember it. So I think I do sockets.index of socket. So I find the index of that guy, and then I do sockets splice, maybe, I1. Anybody? We actually have to test this because I don't know.
Maybe you can delete.
Oops. Oh, wait.
Delete.
No, okay, so pretend we had an array like this, and then we wanted to do A splice that, and then how does A look? I think that's how you remove an element from an array.
There is delete in JavaScript.
I don't think delete removes it from the array, actually. It doesn't change the length of the array. So if we had A, if we go delete A0, say. Oh, that does work. Well, fuck. Okay, I've been doing it wrong my entire life. It depends on the platform. All right, well, whatever. I know this works.
Fortunately, there's only one platform.
Okay, yeah. So let's try that again. So let me start the server, node chat.js, and let me telnet to it. So if I type hello, I should get hello back. Let's see if anybody else can type something on there. Oh, poop. Very mature, guys. What? Oh, my IP address, yes, is that. Port 8000. All right. Obviously, the PHP people. Okay. Killing that server. Okay, so maybe if you noticed when I first joined, I typed hello and I got hello back. So we're broadcasting to ourselves, actually, which is a little bit unnecessary. So let's make it slightly better. It's still a piece of shit, but we can make it slightly better if we just skip one of these, which is if sockets I equals socket, then continue or something, right? That should work. Yeah, or if they, or whatever. So that should fix the echoing problem. Run that, telnet to that, hello. Okay, so excellent. So let's just watch this for the rest of the day. Yes. So networking stuff, HTTP server, TCP server, printing the standard out, all of those things are not part of JavaScript. What is JavaScript is like functions and addition, numbers, strings, arrays, objects, which are hashes in JavaScript. Not much more. JavaScript is a very bare bones language. So JavaScript has a couple of things. Hopefully you won't hack my computer. There's like a math library. There's a couple of things that are part of JavaScript. Obviously, this is too distracting. Kill that. Okay, so most of it is Node. All of this require stuff is Node. Yeah. So what are the debugging options for Node? So recently, so like I said, Node, very bleeding edge, right? Looks kind of snappy and cool here, but wait till you get it in production and right in the gut. So it's one of those things that's under development. So debugging is one of the parts that is half done, but I will show you what it looks like. So let me write a little program here. Let's open up our original Hello World program. So what if we wanted to debug this guy, right? Let's put in a function here. So there's this special debugger statement, which is that. And so when you run this normally, you'll just, I mean, foo's not printing anything even, so we'll just get the original behavior. Sorry. So hello world exit, because foo doesn't print anything. But if you do node debug, you get this little debugger prompt. It's like GDB. Everybody loves GDB, right? GDB? No. Everybody loves GDB. If you don't love it, you're wrong. So you type run, and it will start a node process, and we hit a breakpoint in foo on hello world line 9. Okay, and we can do like a back trace and find out where we are, and we can like list the code and see that we're on that thing. So like I said, V8, the engine on which Node is built, is an incredibly professional and well-done VM, and does include things like debugging. This interface is part of Node, but the actual debugger, the way that it can step and pause the VM, is all part of V8 itself. And so in Chrome, you might use the Chrome inspector thing, where you can open up a website like this and do Control I, maybe? No. You guys know what I'm talking about, right? Option J? Okay, so this thing, right, has like scripts, and you can like set breakpoints and stuff. That is V8. V8 runs inside of Chrome, and the way that it handles the breakpoints is the same thing that we interface with. Okay, so there's several options for debugging in Node. There's different clients to this kind of internal debugger. One is that thing that I just showed you, the GDB-like thing. But there's other ones like Node Inspector, which are more graphical. Okay, there's an Eclipse plugin for it. I'm trying to see if there's a screenshot or something, but maybe not. So anyway, there's some debugging options. It looks like this. It looks just like Chrome Inspector. Yes. So that's the debugging question. Like I said, this thing is total crap, actually. I mean, it's useful, and I use it all the time, but it's one of those parts that is not completely fully baked. This client to the debugger. The debugger itself is fine. Just the client here is. Do you know what I mean by client? The V8 has is a separate process, and it presents its debugger. It has a little protocol, and so it opens a port, and you can connect to that port and issue commands to it. It's a little JSON protocol, and in that way, you can tell it to step into a function and list the source code and breakpoints and whatnot. So yes, there are some debugging options, but generally they're not as well fleshed out as one would hope in other languages. Yeah, I mean, basically, this primitive thing is basically what I'm using a lot. Okay, so I want to do one more demo at least. So Node can do a lot of things at once, right? Because it's not blocking. Okay, so what I want to show you is how we can kind of mash together these examples that we had into one process. Okay, so let me copy that hello world example into hello world server.js. And what I want to show you is that, so imagine you had a sleep loop in your program, right? And imagine you're programming in Python and you had something that looks like while true, sleep 5, or whatever. I don't know what people do in Python. Something like that. Okay, so imagine that was your program, and now your boss comes to you. That's some batch operation. It's happening every once in a while. It's doing some stuff, that programs do. And now your boss comes and he says, okay, that guy over there, that server, we need him to now connect to some website and pull back data every second. Okay, so now you're faced with the task of refactoring that server into doing some new thing at some different interval of time. And so now you get out your calculator and you're like, all right, so he wants me to do it every 2 seconds, but I've got this loop that runs every 5 seconds. So I can multiply the two numbers and find the least common denominator, and then I'm going to activate every time, and I'm going to take the modulo of the whatever. Okay, you're going to do some work to make that happen. Or you're going to open another thread and have 2 threads doing things, right? One doing the new operation and the other one doing the old operation. That's a possibility. Let it just be said that your thread that you create, it's not free. Okay, it comes at some cost. Okay, it's a fine solution for some things, but it's not free. So let's in Node, let's add this thing. Okay, so say this is happening every 5 seconds. I'm going to delete that. Now we have to do something every 2 seconds. We have to get google.com. So we're going to require HTTP. And every 2 seconds, we're going to fetch google.com. And the way that we do that is we do HTTP get, and say, just for brevity, we're going to just print out the headers, okay? So every 2 seconds, we're going to print the headers from that. So console log response headers. Okay, so that's what an HTTP get looks like in Node, and we're going to do that every 2 seconds. So notice we've done this without changing our original program, not at all. The other thing's still running, right? But we can enter this new thing running at a different speed without changing what has already happened. And we're not doing this in another thread. We're not putting more weight on the OS scheduler. We're doing this in a very simple and kind of clean way. So let me just run that and see if it actually works. Why did I call that server? Okay. Excellent. So yeah. What do you think about that? Do you think this is so boring? I cannot wait to go home and have a beer. Why do they not serve beers at these things? Because that's what I'm thinking.
What's something useful?
Yeah, okay. So what can you do useful with this? Before I go on, let me just say, now your boss comes to you and says, okay, now actually I want a web server in there too, as he always does. So now you go in and you just kind of add a couple lines here and you do HTTP server, request response, blah. Response, right, head, 200, and hello world. Let's even put like a little pause in there, because maybe this is like simulating a database request or something. Okay, so that's kind of our web server from before. It takes 1 second to write hello world. Okay, but all these other things are happening. I forgot to listen on a port. S, listen on port 8000. Okay, so now the server is doing a lot of things, right? So let me run that guy. Okay, so it's printing out hello, it's fetching google.com, and now if I curl it, it waits 2 seconds and returns hello world. Okay, so mashing things together is the idea here. You're just kind of taking different inputs, and because we're non-blocking, we can kind of smash them all together into different things. Right, okay, so the question is, the small examples, they look cool. That's a cool, dude. But you know what? Actually, I'm not totally convinced that your non-blocking style of writing code is something that is maintainable in the long run. That is a very good question. And the answer is, we don't know, because this is the first system that's done that. Obviously, so a lot of people complain that what you're going to do is go, oh, I have to HTTP get something. I'm not going to put in real code because it'll take too long. So I have to get something here. And you know, after I get something, I actually have to like take that response and connect to the database. So I have to DB query response headers cookie, and then I have like another function called, because after when you query the database, that's also access that has to be non-blocking too. So you have another callback. And then when you finally get that response from the database, actually now you have to hit the memcache server or whatever, right? So now you have to do something else. So now you have to query database 2 actually, and do this with, you know, here's the DB response. So now you have to use, you know, DB, this is such a contrived example, DB response row 1, so DB2 response, and now you have this. And you know, it grows infinitely inward. And so the extremely naive sort of complaint is, Jesus, I mean, you know, how big is your text editor? I can't indent forever, okay? Like that's not possible. Well, obviously, nobody's asking you to indent forever. You know, you're not forced to use anonymous functions, right? So what you can do is you can take this whole thing, put it up here, and call this after request. Okay, so now we've lost one indentation level, or maybe not. But now we can take, you know, the second one, which is this one, and put it up here, and say, oh, well, this is after DB1. Obviously, I should have like a better real example here, but you can imagine. And then you can take this one and move it out here. So do you have to indent forever? The answer is no. That is patently false.
I mean, the list people have lived with indentation forever.
Yes, you can give your functions names and pull them out of these anonymous functions. Okay, I think the more so that would be the answer to the naive question. The more complex question is you know, is it possible to actually like abstract multiple things here into something that, you know, I'm doing this complex series of database calls, you know, one after another, and I want to present my users with a nice, friendly interface to that and not expose them to the madness of callbacks that are happening under the table. And the answer is yes, of course you can do that. Okay, so what the way that you do that is my contrived example is okay. So let's imagine that you have this HTTP GET is part of a module that you're distributing, and you're saying, oh, maybe you work for Joyent or whatever. Joyent distributes a module that has a function called get, just get, okay, which does a bunch of stuff. And so we are distributing this module, and the exposed function is this guy here. I'll talk about in a second how you actually structure modules and stuff. The way that you actually allow that guy to be presented to the user is that you yourself give a callback. So you give a callback as this parameter, and you keep passing it down. So you do after. So you keep passing it down here. So oops. Does that make sense? So that you can keep passing this callback deeper and deeper into your layers of things that you're doing. I fear that like this example is just wildly too made up to be followed by anybody. Does that make sense? So that you're always passing this callback deeper and deeper. DB2 response. I'm going to distribute this this code after. And now you can call the callback. Okay. So I'm exposing the lower level one. So the users, they just do one callback. But internally, we've abstracted all this I/O that's happening, right, into one callback. You can't remove the callback, though. You can't make I/O happen and not have a callback, a completion callback. That is impossible. But that's good. So the user is explicitly aware that this get function that Joyent is distributing does something on the network. Like, they don't know what. It can be super complicated. But it is not just adding two numbers together. It is going out and doing stuff on the event loop and resolving DNS addresses and getting URLs and hitting a database and blah, blah, blah. And when it's all done with that, it will call your callback. So that was a very poor answer. But I believe, yes, you can abstract and have maintenance and do these sort of things. It's a different style, though, to be sure. And it takes some getting used to. But we write very complicated. I mean, Node itself is a pretty complex program. And so far, we haven't said to ourselves, oh, fuck it. We can't do it. It's too complicated now. I believe that the complexity is not exploding as we go forward. But we'll have to see. We'll have to see what the landscape looks like a year from now when there's real big websites written on it, if that ever happens. Yes? So the question is, what are the Achilles heels of Node? What are the problems here? So I would say the number one problem is immaturity. It's a young platform, and it's a platform that's starting from scratch, right? This is not sitting on top of Python. It's not on top of Ruby. It's not on top of Java. It is literally from scratch. So if you don't have a driver to connect to Oracle, you have to write one, which is a problem, right? For a lot of people, if they can't connect to their database and it's not already there, then that's it. They can't use it. So that is a major problem. More likely, there probably will be a driver, but it's really crappy because some guy just did it, and it hasn't had years of maintenance and bug fixes and that sort of thing. So I think the number one problem with the platform is that it's just young, and that's something that hopefully will alleviate itself over the next couple months or year. I think there's another problem which touches on the previous question of code maintainability and debuggability. There's this problem with event loops, which is this. So you're always killing your stack. Your stacks are very short. So if you have a threaded program, you just call function after function after function, and then you block, and then you call more function, you have more functions. And then at some point you hit an exception. And you've got this huge stack trace, and you can say, I was there, I was there, I was there, I was there, I was there. But notice in this one, so let me just edit this hello world again. So taking out that, let's say we hit an exception in this callback. Or let's make it more, so okay, let's do this. I'm trying to come up with a good example here. So let's do foo as a function here. It's not an anonymous function. Okay, so that's the same thing. Okay, but inside of foo we do another set timeout for another second, and then inside of bar we do we print world. Okay, so that's going to wait 3 seconds. Okay, so let's throw an exception here. And let's look at what the stack trace looks like. So in a normal program, you would see, okay, we're in the main function, and then we called, sleep. Well, and then that dropped out, and then we called foo, and then we called bar, and you would kind of have that in your stack trace. But I think in this one, you'll see that so that we hit a problem. So here's our stack trace. No mention of foo in there at all. Okay, so kind of that middle ground that bar came from disappeared entirely because we dropped back down to the event loop after that timeout, right? So you have these small stack traces, and well, it's a problem. It's something that we are thinking about ways of solving. But it's basically the same problem that you have in the web browser as well. I mean, if you also have the same single-threaded sort of model. It's not impossible, but it does get somewhat annoying to find out where you're coming from. So one way of alleviating that is by every time setting, you could have a debug mode, which we have kind of a tentative branch of doing, where every time you set up a new event, so say start a set timeout, that you would record where you came from, the guy who started you. And then you would go do stuff, and a new event would come out, and you would record where you came from then. And so when you hit the exception, you would be able to walk back through history and kind of see where you are. And instead of talking too much about that, I'm going to point you to some slides that I have on that. Is that how you spell Illuminati? Oh, crap. I'm a terrible speller. That looks like PDF. Okay, so I'll point you to some slides which talk more about this problem and the branch that we are trying to, our plans for solving that. But yeah, it's a problem. In my opinion, that would be the #1 Achilles heel of it. There's other people complain. There's one more complaint which I think is not valid actually, which is that so Node is. I have to be careful. I'm going a bit over on time. So Node is a single-threaded sort of system, right? You're in one process. You're in one thread in this process, and that means that if you're on a 32-core box, those other cores are idle with respect to this task that you're doing on this process. So I don't think that this is a problem because you can start more of them. Okay, there is a kernel scheduler that can schedule processes to these other threads. What we are doing is saying one of these guys shares nothing with the other threads. It is a shared nothing model. In fact, it's so shared nothing that we are kind of putting a boundary between it and the other guys at the process layer, even at the OS process. Not only are you kind of, somehow gated off from talking to other processes, you literally cannot look at their memory. You are enforced by the operating system to not look at their memory. If you want to talk to them, you have to literally open a socket and serialize data and send it to them. I think that's a fine solution. Why? Because programs these days, very large website sort of scale programs that are very large, tend to have to grow beyond one box even. Like using the 32 cores on one box, that does not scale at like Google scale, right? What you need to do is be able to distribute a program among multiple machines. And part of that is speaking in serialized message passing sort of things. And so forcing that to happen even on the single machine level kind of enforces this sort of model of growing. As soon as you grow beyond one process, you have to grow to multi-machines. It doesn't make sense to use Node.js to create a peer-to-peer network. Yes, I mean, I think that is why it is called Node, is that the idea is that you have this kind of simple building block, which is a good kind of thick process, a good process in that. But to scale out, these guys are going to have to talk to each other. And nobody's saying that's an easy problem to solve. They're going to have to share state. That's right. They're going to have to serialize it and use Gossip or use Redis or use something like that. But once you get to that point, like there's different directions that can be taken. And so Node is not trying to solve that problem for you. That's still a problem to be solved. Yeah. It's not preventing you from solving that problem. I want to very briefly, if you guys don't mind, tell you just a second about the kind of larger landscape. So Node is, in one-to-one correspondence with Ruby, there is a GEMS sort of thing. It's called NPM, Node Package Manager. Isaac, who writes this, works in the office next to me. Our internet is terrible here. But it has this nice little command. You copy that. It deletes your hard drive. And then you paste it in here. And what this does is it installs NPM for you. I think I already have it installed even. So I'll just kill that. NPM. OK, so what you can do is install things like a popular library called Socket.io. And it does what you think it does. It downloads stuff. So if you're working with Node, having npm installed helps a lot because you kind of have access to this package repository. And the popular web framework, just so you know and don't have to look around at all the thousands of other web frameworks for Node, is Express.js, which is written by a guy at LearnBoost. So yes, it's a Sinatra-like thing. And I think I'll leave it to you to ask me about other things, but there's a lot of modules for stuff that is invisible. How do you invert the colors? Whatever. Okay. So I'm going to end it there, but I'm going to stick around for a minute until everybody disperses, and then if you want to ask me questions off camera or whatever, feel free. So thank you.